You hear buzzwords like artificial intelligence, cloud computing, and the Internet of Things thrown around constantly. Usually, they are presented as separate features on a spec sheet, as if they are completely unrelated inventions. Decades ago, computers really were isolated machines. You put specific instructions into one box, and you got a localized result out of that same box. The entire process was manual and strictly local. Today, these systems constantly talk to each other. An algorithm can pull data from your phone to adjust a server on the other side of the planet without a human typing a single command. To an outside observer, this level of automation looks like magic. This glowing prompt is the first layer of a deliberate physical architecture. We are going to build this digital world from the ground up, starting with software code and scaling to an automated city. Navigating modern reality requires a clear understanding of how these once isolated layers now function as a single blueprint. At the core of this ecosystem is artificial intelligence. Think of AI as the brain, designed to simulate human reasoning and solve complex problems. Instead of humans writing line after line of specific rules, we rely on machine learning. We feed massive amounts of raw data into algorithms, allowing them to spot patterns, test their accuracy, and improve their predictions without manual programming. To communicate with us, this brain uses natural language processing. This is the technology that allows consumer devices, like Siri, to process spoken English or Hindi and translate our voice commands into actionable code. This software is also altering how we perceive our environment. Virtual reality creates entirely simulated worlds for us to step into, while augmented reality overlays digital information directly onto our physical surroundings. But software alone cannot touch the physical world. That is where robotics come in. We program these machines to execute precise physical actions, like a rover navigating the rugged, unpredictable terrain of Mars. When you merge advanced physical engineering with AI and natural language processing, you get systems designed to mimic human form. Humanoid robots can speak, react, and automate tasks right alongside us. Intelligence is no longer trapped behind a screen. It can now see, listen, and physically manipulate our world. To pull this off, these physical devices need a nervous system. The Internet of Things, along with the Web of Things, connects everyday objects, from refrigerators to air conditioners, directly to the Internet. These objects rely on embedded sensors. Hardware like accelerometers and gyroscopes constantly monitor their physical state and send that real-time information back to the network. This diagram shows the massive output generated by these devices, known as big data. It branches into 5 features. Volume and velocity mean massive amounts of data generated at high speed. Variety means different formats. Veracity deals with reliability. Finally, value means actionable insights. To store and process all of this on demand, we rely on cloud computing. Instead of buying expensive local hardware, users access internet-based servers and software, paying only for the computing power they use. If a single cloud provider isn't enough, researchers turn to grid computing. This connects distributed, remote nodes together to form a virtual supercomputer for specific, highly complex calculations. Storing all this data in one place creates a target for hackers. This diagram demonstrates how blockchain solves this by replacing the central server with a decentralized chain. Multiple network participants hold a copy of the record and verify transactions collectively, ensuring security and transparency. Managing a global flow of data at this scale depends on this decentralized, distributed infrastructure to remain functional and secure. When a single sensor on a bridge can detect a hairline crack and instantly update a citywide maintenance log, the scale changes. By layering millions of these AI nodes and IoT sensors over the cloud infrastructure we've built, the individual device becomes a functional cell in a much larger urban organism. This is the smart city. At this scale, technology automates metropolitan systems in real time, routing traffic to avoid congestion before it happens, and adjusting energy grids based on shifting sensor demand. We have transitioned away from simply using computers as standalone tools. We are now living directly inside a continuous computational environment. Whether it is a rover making autonomous decisions on another planet, or a smart thermostat adjusting your living room temperature, it is all built upon this exact same unified architectural stack. The digital universe and our physical reality are converging into a single integrated environment. The next era of computer science focuses on how seamlessly these once isolated systems can inhabit our physical world.